Hello, welcome to the video notes for lesson 5-8. This lesson is about linear inequalities, day 2. So the first lesson, 5-7, we learned about graphing linear inequalities. This lesson, we are going to be doing the second target mostly, which is write and use linear inequalities when modeling real-world situations. So, we have a real-world situation below. By the way, this begins on page 34 in your notes. And we're going to take a look at the situation. So, the school is having a bake sale and needs to raise at least $200. If they make $5 for every cake and $2 for every cupcake, minimally, how many of each do they need to sell? Alright, so I'm going to go ahead and put a box around the question so that I remember to answer that at the end. And really, this is going to be something we're going to discuss together in class. I also want to focus on where it says at least $200. If it's at least $200, that means there needs to be more, greater than, or equal to whatever $200 is. Okay? So, if you look at the graph, the cakes is on the x-axis, so I'm going to let x equal number of cakes. So then y is going to be the number of cupcakes. Alright, so if they need to raise at least $200, they make $5 for every cake, $2 for every cupcake. So we multiply 5 times x to get however much they make for the cake, and 2 times y for the cupcakes. We add that together, and whatever that is, it has to be greater than or equal to 200. Now, there's a couple strategies here for graphing this. I'm going to use the strategy of turning this into a y equals mx plus b type situation, and watch what happens. This might not be the best way to graph it all the time, but here we go. So I'm going to subtract 5x from both sides. So step 1 was coming up with the inequality. Step 2 is going to be to come up with your points. So subtract 5x from both sides, and I get 2y is greater than or equal to negative 5x plus 200. Then I'm going to divide by 2, and I get y is greater than or equal to negative 5 over 2x. I'm leaving it as a fraction because that doesn't work out to be a whole number, plus 100. Now, I'm going to use y equals negative 5 over 2x plus 100, y equals mx plus b, where m is negative 5 over 2, and b is 100, or it's the point 0, 100, the y-intercept. So that is right here. Now, if I use the slope down 5 over 2, it's kind of hard to do that. If I go down 5, that's halfway, over 2, well, I can't really, because these are going in increments of 10. So down 5 over 2 would be like right here. And down 5 and over 2 would be like right here. It's not quite halfway. But what I notice is, I could, an equivalent fraction would be 50 over 2. So I could go down 50, so from 100 down to 50, and over 2, or 20 I should say, and I have a nice point right there. And same thing, down 50 over 20, and I'm right there. And that works out nice because I have 3 points, and they are in a line or in a row, so I'm going to connect them. Now, I already know that it's going to be greater than or equal to, so it's going to be a solid line and not a dashed line. So I've completed Step 3, to plot and connect my points using the correct lines. Step 4, I'm going to write the equation. So the original equation was 5x plus 2y is greater than or equal to 200. Oh, by the way, if I substitute 0, 0 in, 0 times 5 is 0, plus 2 times 0 is 0. Is 0 greater than 200? No. So the origin is not part of the solution. So I need to shade in the part that is above this line. Okay, now to answer the question, minimally, how many of each do they need to sell? We're going to talk about this more in math. Let's focus on one point along this line. Well, actually, how about this? If I were to look at this point way out here on the edge of the graph, is that going to be the minimum number of cakes and cupcakes? No, that's a number that works, but it's far from minimal. Minimal is going to be as close or on the line as possible. And there are a number of different points. But be careful, we can't pick any point because we're not going to be getting $1 for half of a cupcake or $3 for 3/5 of a cake. So we have to sell whole cakes and whole cupcakes. So one example of a point that might work is this one right in the middle. That's the point 20 and 50. And in math, we'll talk about what that means as an example of something that will work and is minimal because it's along the line. Okay, over on page 35. You have relatives living in both the United States and Mexico. You are given a prepaid phone card worth $50. Calls within the continental U.S. are 10 cents per minute, and calls in Mexico cost 50 cents per minute. Write a linear inequality in two variables to represent the number of minutes you can use for calls within the United States and for calls in Mexico. So we're going to write an inequality for this. Now, first thing I need is to declare my variables. Now, if I look at the graph below, I already know what my x and my y are going to stand for. I'm going to let x equal the number of U.S. minutes, and so y is the number of Mexico, calls to Mexico minutes. So, we're given a prepaid card of $50. It cannot be more than $50. It can be less than your calls or equal to. Now, the U.S. minutes are 10 cents, so 0.1, and the calls to Mexico are 50 cents, so 0.5, and we add those together. So there's your inequality. Now this time when I graph it, I'm going to do something a little different. So instead of converting it to y equals mx plus b, I'm going to split my workspace in half, and I'm going to find when x equals 0 and when y equals 0. Oops. Just kidding. Y equals 0. So when x equals 0, 0 times 0.1 is 0. So I have 0.5 y equals, is less than or equal to 50. Divide both sides by 0.5, and you get y is less than or equal to 100. Over here, when y is 0, you have 0.1x is less than or equal to 50. Divide by 0.1, and you get x is less than or equal to 500. So we have 2 points. We have the point 0, 100, and we have the point 500, comma 0. The x and the y intercepts. So My 0, 100 is here, my 500 and 0 is here. Connect those with a nice straight line. And what's nice is you'll notice, oh, and because it's less than or equal to, it's not a dashed line, it's a solid line. This line cuts through a lot of points. So, the directions for part B say, discuss 3 possible solutions. I want you to come up with 3 solutions, and the way you're going to earn points in math is by sharing those solutions and what they mean, and we're going to decide which way we shade this graph. And hopefully you will do that ahead of time. Alright, I'm going to keep this video short, stop right here. If you didn't understand something, go back and rewatch it or ask a friend or a parent or me for help. Good luck, and we will see you in math.